Hello, and welcome to this new edition of the Foojay Podcast. And today we are going to talk about security.
Welcome to the Foojay Podcast, all your news about OpenJDK.
For this Foojay Podcast, we invited security experts to dive into the world of safe coding and detecting vulnerabilities in your Java applications. And how can we make and keep your system safe? That's what we're going to find out. So let's go around and introduce each guest.
Hello there. My name is Steve Poole. I work for Sonatype. I'm a developer advocate, surprise. But my background is JVM engineering and in the Java space, spent a long time at IBM and Red Hat. And my passion really is what we're talking about here is how do we get developers to learn more about security and how do we help them create safer software?
Hey there, I'm Brian Vermeer, working for Snyk, also as a developer advocate. We got two of them in the house. I've been a long-term Java engineer. Before I joined Snyk, I was a consultant working on long-term projects for both government, but also independent companies. And I run into security because I find it interesting, but also I made some screw-ups over the last couple of years. And now trying to do it from the other side and help people.
Hi, everyone. My name is Anastasiia, and I'm a security engineer. I work at Cossack Labs, which is data security and cryptography company. And data security is my specialization. I do a lot of things related with encryption, like building and designing encryption protocols, end-to-end encryption, making sure that developers who create applications, they do it securely, and basically helping them to design, build security subsystems in their systems. I mostly deal with mobile applications and huge distributed applications like power grids, like critical infrastructure. And I'm in Ukraine, so for the last 9 months, I deal with totally different and unexpected side of cybersecurity.
And I'm Erik Costlow. I'm Senior Director of Product Management for Azul. I work on Java virtual machines as well as Azul vulnerability detection. I've done Java security for about a decade now and helped out a lot with the security of Java 8 back when it had some difficulties. All right. Now, in Foojay, we have a number of community articles that are written at different points of times. And Brian, you've written a couple articles about managing Java dependencies, how to keep them secure. And also, you've written some interesting thing about data transfer objects and their role in security. So can you talk a little bit about your articles that you've written about managing dependencies?
Yeah, sure. I think the biggest thing is that we are always focusing, and I think that developers in general are focusing on creating new stuff, creating new features. We're all already working feature-based. A lot of things we create, security is not yet part of that mindset like scalability and maintainability is, and we should. One of the things is people are thinking about their own code, but have no clue what kind of code they implicitly inherit by their dependency tree. What do I pull into my application? What kind of transitive dependencies come in? How do I need to update? Do I need to update? All these kinds of things are happening, and people are looking at their tests, and their tests are only functional, as in what kind of features do or do not break. What I found interesting is that if I looked at my past couple of jobs and I looked at a Maven POM file from one of the major banks here in the Netherlands, there were things like 3 different XML parsers in there. The question is why? Because people build on top of things that already exist, have no clue when they need to update because that breaks things, etc., etc. So I think managing your dependencies, as much as we do that with your own code, like reviewing your code, doing pair programming to make it better, faster, stronger, and hopefully more secure, we should do the same with things as your dependencies. And in that article, I looked at some things you can do as an engineer. It doesn't need to be hard. Also, what kind of things can we automate, etc. So I think I wanted to give a good guideline to your average developer that wants to think of building new stuff. but how should we take care of what is already existing in your code base?
Yeah, I know. What was it? Which version of Java deprecated the XML parsers? Do you recall that off the top of your head?
Oh,
Come on, Java Jeopardy question there, Brian.
That's a Java Jeopardy question.
Yeah.
We should write that one down. I have no clue which one does that. But one of the things I know, for instance, on XML parsers that are still available in the JDK, all of them by default are vulnerable to external entity injection. People don't know that. So that is a thing you should know about defaults. But a lot of people pull in other things and have no clue that either it's already available in the JDK or are not familiar with that. So let's pull in another one. And that comes with a ton of other dependencies, which in the end, somewhere deep down below, there might be one that is a tiny little bit vulnerable and you can create a domino effect from that point.
Yeah, you've also got like the XML bombs that you can hit people's applications with. But I think in the role of dependencies, what's the phrase? The more, the merrier.
I think the more the merrier is what pragmatically happens. Well, from a design point of view, everybody would say the less the better, but the more the merrier. Yeah, I love that phrase. Let's. I think that paints the picture quite well.
Yeah, the more libraries we come across, the more problems we see.
Yes, definitely. It's a numbers game in the end, right? But yeah, true. Absolutely.
Your other article refers to data transfer objects and their role in security, which is an aspect that I've actually seen a number of vulnerable systems fail to implement. So can you talk a little bit about the role of why you would want a data transfer object versus just taking your core entity straight from a database or a NoSQL database and just spitting it out there serialized to someone on the internet?
I think the most important part is it starts with the design of your application. You need to think security from the get-go, from the start. If I have my domain entities contain all sorts of meta information that you probably might think it doesn't hurt if people know it, but if you combine certain things like IDs with certain endpoints, it might end up that with that knowledge, you can disclose information that you don't want to get out. So what you want to do is you want to separate the logic on the business side from whatever hits the client, either if it's a website or a mobile application, only show what needs to be shown. For instance, if you don't need an ID of a client for a certain use case or for a certain call, don't give it. If you do need it, then you have a purpose. If you don't, you might want to take that away. So with the DTO, with a data transfer object, you separate these two layers from each other, and you only give from one piece, from one part of the subsystem to another. You only give the information that is needed. What happens alongside if you do it with domain entities? And in the beginning, it might be a very small kind of MVP situation, but things grow over time and new things will be added. And are you still aware of what's happening or not? And if that is the case, then it can end up that in a certain REST endpoint, you, by accident, you give the full entity that discloses too much information that can end up in a, PII violation, or basically a violation of personal identifiable data that's getting out, and then you have a data leak. So I think the separation with DTOs is a good start. It's a part, it's not the end, but it's a good thing to use.
Right. And Anastasiia, I see you've dealt a lot with that in the field of encryption.
Yeah, absolutely. And I totally agree with Brian here that having the separate middle layer, let's call it this way, right, to process some business logic has a huge benefits for encryption, for data privacy methods and mechanisms. For example, the thing that I see right now that is rising is field level encryption, which means that in the systems, we have certain sensitive fields. It could be PI, it could be PHI, right? It could be any data sensitive for your particular application, for your particular use case. And what systems it creates that in the middle, we have some kind of proxy, some kind of backend service that will encrypt and decrypt those sensitive fields. And this type of middle layer allows to separate encryption and all related things with encryption, like key management, logging, proper error handling, masking for users that are not allowed to have access to plain text, right? We can mask data for them. So in this middle layer, we can put everything and build like an isolated environment, a fence if you want, with authentication. And it works great from data security perspective.
Yeah, also probably if you can encrypt some of the information that's like unique to somebody's account, it prevents them from making a lateral movement into someone else's account.
Absolutely. And with field level encryption, the data breaches, they become not so serious anymore because the data is encrypted on a field level. It means that the data is encrypted somewhere before it gets to the database, right? So good luck having access to the database. The most important fields are encrypted there.
Yeah, I think one of the things I regularly see with a lot of Java applications that use an entity ORM like Hibernate is a situation where you take what is the Hibernate entity for JPA that has the annotations like @ID or the other elements there, and then that's just serialized out to a REST API. So all of the clients who call your API have your individual data keys. So you can, as a consumer of that API, just go start combing through other IDs, and very frequently you will get other people's information returned to you because there's no break between a REST API and the Hibernate entities that you get to query. You have a lot of similar stuff in the NoSQL space, but those keys tend to be a little more random, whereas in the SQL world, they're frequently auto-generated and incremented.
Yeah, absolutely. And if you think about it, we make the design more complicated for us as for developers and architects, right? At the same time, we decrease the chances of security weaknesses and vulnerabilities significantly. So this is exactly the case when a little bit of engineering gives better results in the future.
The thing I see with this, with security in general, right? And we talked here about, dependencies and things. Why do people pick extra XML parsers? Well, they don't, but they have a problem they want to solve. And they go look for some example and they pull in a dependency. And that pulls in a bunch of other dependencies. But they don't care, they don't track it because developers aren't measured on these things. Security is not a function that they're responsible for. We know they should be, but it's just been factored out. If security was like performance, then there'd be a lot more focus on it. But because it isn't, and because developers are so pressured on productivity, that they're going to go and find those extra libraries that help them do the job quicker. And they're going to pull in more dependencies because that's what they're being paid to do. And, the things we're talking about, how to help them do things better, it's really strange, but basically the ones that stick are the ones that give them other benefits. So like having data objects gives you performance benefits, and just luckily you get an extra level of security. Quite often the way that people fix the way that their security gets better is by accident, and we need to figure out how to make it by design.
And in terms of design, some of the things that we've talked about is the role of getting libraries, the role of having a couple different XML parsers, updating those, and then creating a layer in between, like you were talking about before, in terms of, maybe the developers aren't the ones who build the cryptographic solutions. So Anastasiia, I know you've written a couple articles about like cryptographic failures in RF encryption. And for Java developers, we tend to go after the Java cryptographic architecture and just the baked-in components. But what should we know about some of the failures that people get whenever they try to design their own cryptographic systems?
Well, a short answer, you should not. If you don't have a proper cryptography education, please do not design your own cryptographic protocol or subsystem, even if it looks really easy to do so. because probably you're thinking only about successful scenario, but you don't take into consideration all the worlds of typical cryptographic mistakes, starting from constant time computation, through side channels, through different kind of attacks, yada, yada, yada. Cryptography is complicated as a math, as a science, but the design of cryptographic systems, it's even more complicated because it's a mix of software design, right? Resilience, security design, yada, yada, and cryptography. One of the things I would like to mention here is that sometimes the mistakes are not obvious for developers just because these are different areas of thinking, different mind maps. If you know about latest metrics issues, the metrics, the end-to-end encryption protocol and the software built decentralized signal kind of, they have really great end-to-end encryption protocol, but lately they published a bunch of vulnerabilities, a group of cryptographic experts audited the matrix protocol and the implementation, and they published really fascinating papers. Why fascinating? Because they enumerate a number of problems, starting from cryptography design to implementation mistakes. With cryptography, it's always like that. You can have really large issues on design, but then you will put a wrong parameter in a wrong place and you will have problems with implementation as well. It's really complicated. And in my job, of course, I'm biased because I mostly deal with bad and broken and imperfect cryptographic systems. But what I see that when developers try to do that, please stick to existing solutions. Or if you think that your use case is different, please try to get assistance or consultancy from security engineers or cryptography engineers, because cryptography is a science. There are people who are trained and skilled to do this.
Can I also jump in and say a cryptographic joke, because there aren't that many of them, I don't think. All right. In terms of designing your own crypto system, there's an old crypto thing called ROT13, which is you just take the alphabet and you rotate it by 13 characters. But why does Santa Claus use ROT 12.5?
Go on then.
Because Christmas has no L.
Oh.
Okay.
Okay. You've obviously got a book of dad jokes. Well done.
No, I just kind of make up all kinds of terrible things because it gets everybody to groan, and then it makes conversations and meetings shorter.
I have to remember that one.
So in terms of some of the different types of vulnerabilities, like the things that people will design for public crypto systems when they have a difficulty or a security problem in them, there's the concept of CVEs, or common vulnerabilities and exposures. And Steve, can you explain what those are and how they pertain to Java developers?
It's been around for a long time, and it's a scoring system. So the idea is, how do you assess the impact of a vulnerability? So you score it, and it's been lost in the mist of time. So I'm not even sure when they first started. They've been around for a long time. And it's basically a whole bunch of things that look at how easy is it to exploit the vulnerability, how much damage can you do with the vulnerability, how likely is it that somebody may have this. So some of these vulnerabilities get low scores because they're very hard to exploit, and they're very hard to, or they're very rare. And so when you go to any of the websites and you look for CVEs, you'll see scores, and you'll hear us talk about CVE 10s, which is the perfect score, which means that it's the perfect vulnerability for the bad actors to exploit, all the way down to things like CVE 1s and 2s. But a couple of things to point out is that there's a public database for these things. So obviously there are people out reporting these. There is a process when a vulnerability is reported, and anybody can report one, then there is a process for validating that, obviously by the people who own the reporting, the owning tech. There's a process for scoring it, and then it's made publicly available, and hopefully by the time the CVE gets published, there's a fix for it. But the thing to point out is that there's public databases for this, but there's also other databases. I mean, we have one, Snyk has one, other ones where, because we have researchers who are also trying to find these vulnerabilities. The takeaway is, yes, keep looking at the public ones for sure, but also, make sure that you're aware of the other solutions for these things. And the other thing, the way that CVEs are scored on the idea that you as developer or whoever, wherever you're running the code, is doing it in a sane way. So if you are a developer and you've given everybody root access to your system, then all bets are off, and any low value CVE might actually be effectively very high. So understand, if it's a high CVE number, go fix it now. And if it's a low CVE number, still go and assess it, because you never know, it might be important.
All right. In terms of those CVEs, they come in through libraries, a couple other means, through individual applications. But within the JVM, we have a couple different layers. Like you have the JVM itself, you have the operating system, you have the hosts and buckets and external things. So Brian, can you talk a little bit about what are some different security layers and tiers that Java developers should be paying attention to?
You already mentioned the JVM is one of them. So updating your JVM or updating your Java version to a newer version that is patched is something that's critical. But think about this. Like we used to think about our application alone. So that means our code or the stuff that we created and put on our Git repository. Well, that's one layer. That's the most top layer, I guess. Then below that, you have the dependencies. We already discussed that. Everything you pull in to make your application work. But your application does not work in a vacuum. It comes with an environment, say a container or something like that, or an operating system. Well, if you look at, for instance, Docker containers, people pull in base images from registries and base their application that is in a container on somebody else's container and just pull things in. Is that image good? Is it based on an operating system that contains a ton of binaries that you might not need? Are these binaries outdated and have CVEs as well? Very, very important. A very funny one was, of course, Image Magic, like way back, which was so tragic they called it Image Tragic, and that's not a joke. It's actually true. And if it comes with your operating system and you put that on in your container, well, then you're part of that chain. Then you have things like your infrastructure as code, your Kubernetes instances. How did you configure them? Did you give them enough privileges or too much? So there are so many different layers. And if you look at a single system, then you definitely have your operating system. If for Java, your JVM, and then everything you pull on top of that. So you can look at it from different angles. But nowadays, everything is part of your code or your code base or your configuration, which again is part of your code base. And that means that in the end, as a development team or DevOps team, you are responsible for the whole thing. And I think developers or core developers do not yet grasp that idea and still are with their eyes and their focus on their own code and maybe a bit of their dependencies, but that's pretty much it. So we have to look further than that, because the rest is also part of the application or the landscape or whatever you might call it.
Yeah, I've seen that a lot where people say, that's not a problem in my code, that's a problem in Apache code. Like, you don't just inherit the benefits of what the library does, you inherit the drawbacks of the other things that it does.
Absolutely. And if you think of it the other way around, like say you are my manager or you're the CEO of the company I work for. I am your head of engineering, or I lead that engineering team that makes that service. If something goes wrong, you come to me, you come to my team. You don't care if it is a dependency in code, if it is a Docker container that caused it. In the end, my team, me and my team need to solve this, are responsible for whatever comes out. And if you take it from that angle, people are like, yeah, sure. We're also responsible for the performance, like Steve was saying earlier, and that is and you can measure performance. Security, not. And it goes well unless you're not getting breached or nothing happens. But if it goes wrong, it comes back to the team, and good DevOps practitioners know then we have to fix it.
Yeah, a place I've seen this go awry with Java developers in particular and Java application operators is with like jar file signatures, because there's this whole capability there where you can sign a jar file. But there's a question of who signs it, because you don't have to sign it to publish. So you have a lot of these unsigned jars. And of course, everybody who ships software will be like, I'm not going to sign this third-party library that I got. And it's like, you're the one who shipped it. So when you kind of take over custodianship or provenance at a part of the software supply chain, you should cryptographically sign whatever you are shipping so that people can actually look and say, like, that's the jar file that I got from, XYZ Co.
Yeah, and that's a lovely idea. But what we know is that almost nobody checks them.
Yeah, nobody does it. Nobody signs it. Nobody checks them. Yeah,
well, even the ones that do get signed, it's pretty clear that it's not checked. All those places where you can download code, binaries, whatever, and there's some signature, people don't check them. It's a very irregular activity.
Well, but that's different depending on the ecosystem. In different ecosystems, people actually check the signatures of the third-party libraries. Right, in iOS, if I'm not mistaken, there are several package managers like Copods or Apple Swift Package Manager. They have this step, and it's not optional. But in iOS, you can imagine that Apple has very strict ways for developers to work with their code, and signatures there with the developer profile. It's a huge headache for developers, but yeah, it might worth a risk. One more thing here to mention is like circling back to CVEs. As Steve mentions, V stands for vulnerability, right? But not everything that is wrong in application security becomes a vulnerability. So what I see often that developers really, or security teams, they really focus on vulnerabilities and on these CVE scores. Like, let's ignore everything that has lower score. But except for vulnerabilities, we still have CVE, which stands for weaknesses. And in OWASP top 10, which enumerates the largest top 10 risks, right? These are just typical mistakes. In the latest OWASP top 10, there is a separate section, like one of the risks, which is called insecure design, which is basically, and this was the first time in 2021, it is the first time in OWASP top 10 where we have design section suddenly. And the goal is to focus developers' attention on the lower beginning side of SSDLC, Secure Software Development Lifecycle. Let's start thinking about design. Let's start thinking about weaknesses and potential weaknesses before we even go to code and secure coding, dependencies and dependency management, and looking and fixing vulnerabilities.
So fundamentally, that's the sort of thing we've got to figure out, is how do we get the developer communities to pay attention to these things? And the information's out there and it's getting better. So absolutely, teaching developers how to write safer code is one of the ultimate goals here. I just want to check, because one other thing I want to say about CVEs, because it's something that we've seen change, and this is this thorny question of how long do you have from a CVE being reported to you actually fixing it? And unfortunately nowadays, with the very high severity ones that come out, the chances are that it's already being exploited before it gets published. So again, not trying to be a doomsayer here, but it's important to people to understand that the other thing they have to invest in is being able to apply these fixes, especially the high severity ones, as soon as physically possible, because you just don't have time anymore to wait.
Yeah, you actually have to patch this stuff, because it's not about the 0-day attacks, but let's say 30, 60, 365 days after the vulnerability came out, if you're still trucking along with that old vulnerability, somebody's going to come by. You can go to things like exploit.db or, GitHub, search for the CVE, and then often POC, and you'll just get a bunch of exploit payloads that you can use to attack stuff. And the longer that vulnerable library sits inside of your application, application that's running, the more likely it is that somebody's just going to come along and find it.
I also think that we do not only need to focus on the high severity ones, because I think it's a misunderstanding for folks like, oh, this one is low, the vulnerability scores is low if it's a CVE or a CW, whatever score it is low. We don't need to fix that because there's no direct attack path. And I think there is a problem as well because different things can connect together. If you look at security breaches, it almost is never as big as, well, we probably will cover that later, the Log4j one, which was a direct hit. It's probably something that connects to something else, to something else, to something else. So a chain of problems connected to each other. And then in the end, the CVE might have a score of 3 or 4, like reasonably low, but because it's part of a chain, it can still be harmful depending on whatever is in your application. And it can be a combination of whatever is in your application code, the binaries that you pull in from the operating system, the Docker container, everything all together combined. There might be a path that even a small CVE can be very harmful to you. So just watching on scores and saying like, is this big or small? And hopefully we can get to a point that we get to 0. And I know that's of course not possible for most companies, but just keep that in mind that a CVE is, or a vulnerability is not always a direct hit. It can be in a chain of attacks and harm you mid-air, basically.
Yeah, so I personally like working on different analogies or just ways to make the security topics fun instead of the boring old risk guy who comes over and talks to you. And one of the ideas that I'm working on now is the concept of like CVEs as Pokemon, because you have for Pokemon for years, they've walked around with that theme song of you gotta catch them all. But the fact is there's so many of these little animal Pokemon things around that you know that not all of them are particularly important, but there's some of them that you have to focus on at different times. But still, the goal is to become the world's greatest Pokemon trainer or CVE catcher in an enterprise capacity. So I think I got to workshop that a little bit, but I might be onto something.
I'm curious what the title of the workshop will be.
No, you just got to workshop a joke where you kind of try different permutations of it to see how it works.
Absolutely.
Well, we could try that. That would be cool. Pokemon workshop for Java developers. Yeah. So, of course, the real other challenge in all this is that these CVEs aren't necessarily in your code. In fact, the chances are they're not in your code. They're in one of these dependencies that you pulled in, or the dependency of the dependency of the dependency you pulled in. So you've got to know you've got it, which is a challenge in itself. And then you've got to figure out how you're going to fix it. Obviously, if it's a dependency tree, you always have the ability to override those versions and pick some new version, but then it's got to work and you've got to test it. And you can see why, even though we all understand why this is important to do, it's still hard for developers and businesses to get their head around how they do it effectively. So it's still a technical challenge because the figures are something like 80-90% of your application is written by somebody else, and therefore 80 or 90% of the CVEs that turn up, actually probably 100% of the CVEs that turn up, are in somebody else's code, and so you have all that challenge as well.
But if you want to overwrite them, that means you need to know your build system, Steve. Come on, who knows what to build? Who knows what to build the steps of Maven?
Oh, come on! You don't have to use it.
People are still doing clean install. So
that's what I guess.
Yeah. Yes, exactly. But I think that's the point. Like, people don't know how some of their tools work.
Ooh.
And that you're able to overwrite these kind of things. Which dependency wins? Either if you're a Maven guy or a Gradle guy or whatever.
Yes,
I think it starts over there already.
Yeah, library maintainers, they don't make this work easier, because remember the recent drama with OpenSSL, right? OpenSSL has announced that they have the critical vulnerability, and everyone was like super prepared to what we have. Like, this is an OpenSSL. OpenSSL is used everywhere. Okay, almost everywhere, including these dependencies of dependencies of dependencies. And many of these dependencies, unfortunately, link OpenSSL statically into their code, which means that they have linked a certain version of and it won't change until you update the dependency, right? And everyone everyone was super prepared, and we were waiting forward for this critical vulnerability. But then OpenSSL maintainers said that, well, okay, we read things, we decided to decrease the vulnerability level from critical to high. So they announced 2 high vulnerabilities. High is still high, especially for OpenSSL. But when we actually read what these vulnerabilities are about, they are about parsing email from XML, right? Emails from TLS certificates, to be precise. It's not something you do very often in your application, and it's not something libraries use OpenSSL for. So the use case is very, very rare. So what I see from the community, the reaction was, oh, okay, these are not so important. We can skip this update. Yeah, it still has 2 high vulnerabilities, but come on, we don't use this code, right? So what I'm saying that we still have a lot of libraries, extremely popular libraries, basically things that the whole internet is working on. And when those maintainers release new patches for new vulnerabilities, it makes everyone makes everyone suffer. It triggers and alerts everyone.
Yeah, so that's actually one of the things I think Java gets right, is the fact that the libraries are still there, effectively dynamically linked, because it's just in time compiled, generally speaking. So you can actually see what some of the dependencies are. And theoretically, you can update the JVM to patch vulnerabilities in the JVM that gives some level of control over the aspects. Unlike OpenSSL, where when you statically compile in a vulnerable version, you are effectively screwed forever on that distribution. And I pasted a link in here. I think it was a couple years ago that, GraalVM was statically compiling secure random or random seeds into the compiled binary.
Well, to some extent, that still happens every now and then. I mean, I know in a bunch of companies, they're not using a package manager to download the packages for you. So you have a manifest. No, they basically copy and paste either the complete jar into a separate file or put it in the class loader, or even worse, they copy paste parts of the code and put that in their application. So it's very hard to find. I know that some engineering managers also that I know had a bunch of problems by solving that. For instance, with the Log4j situation last year, that people statically had that code, that vulnerable version, as part of their Java application compiled. So we have the opportunity not to do it, and still, in some cases, people still do it, unfortunately.
Yeah, I don't know if you guys have seen the whole bunch of jar files committed to the source repo.
But why?
I don't know why people do it, but they just download a bunch of jar files, shove them in the source repo, and then they commit that as a big old binary blob.
Yeah,
it happens.
It's a nice, easy way to get your binaries distributed. Put your build tools into your source repo. Yeah,
it guarantees they'll be there when you look.
Yeah,
hey, it works on my machine, right?
Yeah.
What could possibly go wrong, right?
But you see, this comes back to what I was saying about the visibility of this, is that we chuckle at this, but it is an education thing. It is understanding why these things are not the right thing to do. And so we can teach developers that, but we've also got to teach them to take a better look at the tools they use. You know, one of the things that so often you find that people just do the Stack Overflow thing. How do I do X, Y, Z? Go Google for it, and Stack Overflow says, use this tool. And they do it. And, you know, one of the things when I talk to developers, I say, can you tell me the difference between wget and curl? Why would you use one versus the other? And it's like, I don't know. I just Stack Overflow one, and that's what I use. You know, they have different use cases, and it's like all these tools. You should know a bit more about the tools you use, especially around the security space of this.
All right. So throughout this discussion, we've been coming to kind of 3 key roles, which is the developer, you got DevOps, so you have the operator, and then you have an architect. So let's get into what are the individual security responsibilities for each group there.
Well, first of all, I think you have to operate as a team and communicate, which is sometimes hard. And yes, we laugh about it, but it sometimes is. I think for an architect, it starts with design, like what kind of stuff do we have? What kind of data, for instance, do we have in our system? Do we actually need that data? How do we distribute that data? Do we have separation of concerns between subsystem A and subsystem B? The things we already talked about with DTOs, for instance. But that is an architectural kind of thing. If you look at the developer, and then I think developer and DevOps are nowadays a bit intertwined. There's no hard boundary between them. I think that was the intention of DevOps in the end anyway. So creating, say as a developer, you're creating stuff. And that means that you nowadays think of, hey, am I scalable and is the code maintainable? But now if you are an autonomous team, you also need to make sure that your solutions to that specific problem are safe, are secure, that your code is secure, that everything you pull in, your dependencies, we talked about that a couple of times, are secure and stay secure over time. So redo that analysis. And for DevOps, it also means that making sure that, am I able to, for instance, deploy something right away? Say we talked about 0 days, and I find out right at this moment that something is wrong. How much time does it take for me to change out that simple library? Just take a simple solution, a simple library, I switch it out, rebuild my application and distribute it either to production or distribute it to my clients. That sounds super easy, but in many cases it's not. Because it takes days, weeks, months to build that application, and then you have a bigger problem. And I think that is something you need to address as well. And I think that is for the DevOps part, like, hey, do we have pipelines? Do we have all these tools available and all these new kind of ways of building things that we actually can distribute it right away so that my customers and my users are not experiencing the problems we try to warn them for.
When you have pipelines, yes, but there's also a lot of things like infrastructure software or Java things that people get, and they don't run it through any pipelines. Like you just go download like a Kafka and then you put it up. You don't really need to build it because you don't. So generally speaking, people don't have large pipelines for all pieces of software.
I absolutely agree. I just picked a few things out, just to see that there's a shared responsibility between all of the folks to know what's happening, to know where the problem is, and the problem is basically everywhere, and that we communicate about that and be aware of that it can happen everywhere.
The deployment part, the build processes have to be automated, and you have to know what software you've got in there. Developers have the same responsibility because they're the ones that are choosing the dependencies. Somebody somewhere goes, I need that XML library. And so they've got to be better at making those choices, and they've got to look harder at those choices. And sometimes it's going to become, don't take that whacking great XML library for that one function, go write it yourself, because in the end of the day, you may be safer that way. And the other thing that we've got to do, coming back to things like the CVEs and the OWASP thing, there's a whole bunch of rules out there and guidelines on how to write safer software, even from input validation to other things. And we've got to get our developers to pay attention to those. They somehow, and I'm not sure how or why, but over the years, that sort of part of software engineering has disappeared, and we need to bring it back. So that one. But the build and the build stuff as well, because as Brian said, you've got to be able to build this stuff quickly.
Yeah, totally. But also, I think that in our imaginary team with developers, DevOps, and architects, security engineers are missing, because there are still lots of work to do, to be done, like risk assessment, threat modeling, using different checklists and standards like OWASP, SVEs. Who will do this? Developers? No, they are busy with features. They are busy with releases. DevSecOps, DevOps, they are busy with pipelines, with infrastructures. Architects, they are busy with design, Right, but still, there are so many things to do from security perspective, and security for business is just one of these non-functional requirements. As we mentioned previously, it's not something that can be seen. It's more like a negative, like waste of money activity that potentially can prevent huge money losses in future. So someone should work on a strategic level. Someone should work on thinking about the future, thinking about loss prevention. And these could be security people, security officers, security engineers, you can call them whatever. They have different roles because security engineering is a huge umbrella term with different specialties inside. But also a security managers, if you can say it, someone who guides the team using SSDLC, right? Someone who will tell developers what is good and what is bad from SSDLC perspective. These are the roles, and sometimes these people are different. I mean, we have certain roles and people are doing only this job. And sometimes we have something called a purple team, or security champions, meaning that we have an ordinary software engineers that do security, that perform certain security functions.
Okay, yeah, plus one on that as well. Yes.
I think you hit the nail right on its head there, Anastasiia. I mean, I think that, and that comes also back to what Steve was saying, that a lot is in education as well. So if you don't have the security folks, the security team, the security engineering team, how big you ever want to make it, as an engineer, I come to a conclusion okay, I need to do something, but I'm not sure how to handle this. Then you need to have somebody to go there. And there needs to be a line between the security team and the development team, if we can call and hopefully there is a security champion that is that proxy between there. But if it's not, there still needs to be guidance from a security perspective, or else we will fail miserably, I'm afraid.
So one of the things I've been really interested in working on is the fact that Java has done a really good job of becoming effectively a blue-collar programming language so that you don't have to learn the ivory tower development styles. And it was never the first to do anything. It wasn't the first to do memory management and free people up from having to know about pointers. Whereas people used to have to learn all sorts of intricate libraries to do, database calls or XML parsing, Java introduced a lot of those through standard APIs. So one of the parts that I'm really interested in working on is the role of how can we make the JVM essentially free the developer's mind from having to worry about a lot of the security flaws of today. And what are some of the ways that we can look at what's gone on in the industry over the last, 10, 15 years and make Java start automating some of those things again? That's
a very good question. And I think it starts with secure defaults. A lot of them are secure, but I already mentioned before that the XML parsers in Java are by default vulnerable to external entities. For instance, in a lot of other languages, this is already solved. Other things are, obviously things like deserialization. It's the gift that keeps on giving. So there are features we can work on to not enable more of these problems. But I would love to give the floor to the others as well to see what.
Yeah, well, there's because I'm like you. I'm going, how do I answer this question? So absolutely, we could imagine doing something with serialization to reduce its hit, but that's going to break a few things. But it's still worth looking. Modularity is good. Reducing the scope of classes so that you can't load things. That's cool. We've got seal classes, seal jars, things like that. There are a few things out there that we could use better. I think serialization always comes up as being the number one thing. Because it's easy to do that. There's no real security model within the JVM. So there's no real separation between user code and system code, which some other systems have. So, that might be a possibility. But I don't know. I look at Java as it's mostly just a programming language, and this isn't really a Java problem. In fact, in some ways, Java is just slightly better because it's strongly typed. We can analyze the bytecode better than some of the scripting languages. And with, I mean, almost just by accident with things like Maven Central, where you have to own the domain of the package name to register it, that cuts down a whole bunch of the classic sort of attacks that you get in some of the other repos. But as a I don't know, is there a fundamental something different we could do with Java? I'm not sure there is.
Well, one of the things that we've been working on is the role of making the JVM actually know the components that it's running and report those to an off-stream system so that you can go back and look and say, I've used this vulnerable version of log4j in the past. And we just launched some capabilities to do that. So it's a lot of, tracking what the JVM has run. Have you used deserialization in the past, which is one of the sets of security flaws? Have you used what these components are? What if in the process of just-in-time optimizations that a JVM does, if it recognizes you don't actually need these modules, so you can start to remove them and make them inaccessible in future runs, rather than having to force the developer to JLink in advance and remove them, you could effectively take advantage of the things that the JIT knows to improve the security of something as it runs.
Yeah, you're quite right. And to be honest, take it further than that, you can just do the Graal thing and just compile your Java code to native. That cuts through a lot of these issues.
Yeah, but then you statically compile vulnerabilities in a way that only the original operator can update later.
Well, it depends if the vulnerability comes with it, but
right, but now we're back to kind of the OpenSSL style where people end up statically linking to that older vulnerable version, and now you have that there in perpetuity. All right, so Java got its start in terms of tiny, low embedded devices and has really moved up to the enterprise. And Anastasiia, I know you work on a lot of tiny IoT devices. Do you have any security insights into what goes on in that ecosystem?
Yeah, this is a disaster. Okay, so being honest, the thing with these small IoT devices, or like even industrial IoT, like IoT, this joke, S stands for security, right? The thing with these devices is that often they don't have update or upgrade path. So the code that you ship on these devices probably will work there until device is broken, right? Of course, it depends on the system, depends on device, depends on the architecture, but really in many, many cases, you ship only once. And you can imagine that you ship with all the vulnerabilities that you had on that moment in time. And in security, we don't have the saying that your system is secure. No, your system is always insecure. Even if you don't have any existing vulnerabilities, as for today, as for this morning, on the evening, situation may change. New CVEs, new vulnerabilities. So it's always a race. And with these IoT devices, you don't participate in this race anymore, right? So this gives one of the major risks. So the less code you have on this device, it's kind of better because the probability is that you will have less vulnerability there. Another issue is that with low power devices, again, devices are different. Raspberry Pi is also considered as IoT device, but Raspberry Pi can have, like my first PC was not as powerful as modern Raspberry Pi, right? So Raspberry Pi has a lot of, it has good CPU, has a lot of RAM, has a lot of storage, and can work on Linux. But when we're talking about really low power devices, it means that the components, libraries we use for them, they are different. Just because we don't have enough RAM, we don't have enough space to create like large applications. So we often end up with C language. Again, that's a disaster from security perspective. And the latest OpenSSL vulnerabilities is a good illustration of how C is still flawed in 2022. For many, many years that we work with C, we still have the same mistakes again and again and again, right? All this combined gives us millions or even billions of insecure devices. And don't forget that in many, many cases, there are certain default parameters, and IoT vendors, they don't know about secure by default principle. They use something by default in admin by default principle. So many of these IoT devices, even if they allow to configure secure settings, by default they don't have those. They have like this default insecure configuration. So it becomes the user's responsibility how to configure their own device. And of course, some devices need to communicate. And here we open the whole chapter of insecure communication, because these small and, stupid devices, they don't have opportunities to use normal communication protocols, to use TLS 1.3, for example. They end up using insecure Bluetooth. And Bluetooth, as you know, Bluetooth was insecure protocol without any built-in encryption for 4 versions for a long time, right? It means that developers who create applications, who create firmware for IoT devices need to think about all these security issues. They need to think about their dependencies, amount of code, about how not to make mistakes in C, memory management, how to transfer data between devices or devices and the hubs in a secure way. And of course, sometimes to take into consideration the physical attacks, like the side channel attacks that allow to leak data, to steal data based on the timing, based on the CPU, like electricity consumption, yada, yada, yada. IoT security is very, very, very complicated. And the problem is that we already have billions of insecure devices around us, and it won't get better. It will get worse year after year.
Yeah, I was talking to a guy, Limited Results, who did a lot of security analysis using voltage glitching on ESP32s, and he like hacked them in a way that was totally irreversible. So the chip was just, it was forever hacked. You could never reverse it. So the device was compromised for good.
Another example is NFC cards. You know how you use your banking card or your card for like metro, for transport in your city. So these are NFC cards. These are simple cards with NFC modules. And right now, a lot of fintech applications like cryptocurrency applications, they start using those cards. So in most cases, these things are vulnerable because they use NFC, which is, again, doesn't have any built-in security measures. This is just a protocol. And again, it's a developer's responsibility to build in some security. And for last, 6 months, I've seen so many insecure systems with IoT just because it's really, really, really complicated. An approach that I would like to kind of advertise here, to focus your attention here, especially with IoT, is defense in depth, right? Because we cannot have a perfectly secure device, we cannot have a perfectly secure firmware, software, yada, yada. We need, as developers, we need to build in a lot of security methods. Like to build in defense in depth, meaning that we will have a lot of security controls on different levels. If we're talking about device, starting from physical security, physical anti-tampering measures, going through firmware security, depending on which operating system our device operates, if it's like a real operating system or if it's this small RTOS, real-time OS, like smaller operating system. We need to configure those operating system correctly. We need to disable, it's called Linux hardening. We need to disable all the packages we don't use. We need to have this secure configuration, yada, yada. Only then we can go to the software level, to the application level, where again, we remember all the OWASP guidelines and cheat sheets. We care about secure coding and implementation security and application security. Then we have a layer of data, because our devices, they do something, they operate on data, and if we are unfortunate, they operate on sensitive data, right? And we need to protect those data. We're talking about data at rest encryption. We're talking about application level encryption. Then these devices, they send data somewhere. So transmission security, secure communication protocols. And of course, usually it ends up with some device hub or device control server, right? If there is some entity, some backend service that can control, that can communicate with these devices. So we're talking about its security as well. So with IoT, we have all these multiple levels, and we need to work on security on each of this level. And if we are lucky enough our system will be kind of secure for next kind of couple years, but then insecure again.
Well, then if we're lucky enough, we get to start dealing with the human elements, because it's the way that people approach these systems. Then all of a sudden they get creative once your system works. So like with parking meters and stuff, they'll have the IoT solution. It's there, it's solar powered, it's independent. You put your credit card in, or you tap it and pay by app, and you can pay. And so what frequently happens is somebody will walk up, they'll slap a broken pay by this app, and they'll just put a sticker over like the QR code. So you'll go there and you'll pay to park, and you'll get a message that says, thank you for paying. You get a bill. Turns out you paid somebody else. So now first you're out the money that you used to pay. Nobody even knows who. And second, you get a ticket for parking unpaid.
Yeah, absolutely. And with increasing amount of these smart devices around us, we will have more and more issues like that. You can remember latest issues with smart cars, right? With Tesla, that people just go nearby the car. They use NFC again, insecure protocol. They use NFC reader, and they can brute force, or like attempt to brute force the car keys and just unlock somebody else's car. This is the future that we have.
Or the repeaters, where they have one person go stand next to somebody who's in the restaurant. It transmits the signal real quick to somebody who stands next to the car, and then they just steal it because the key looks like it's in the car.
I have a car. I won't tell the manufacturer, and there's the remote key that has.
You have a car for now.
Oh well, yes, and so the remote key is one of those that the bad guys with the right device can remotely activate, and so steal your car. And so the advice is to keep the key fob in a metal box, and that's what I do.
Faraday cage, right? Keep everything in the Faraday cage.
Exactly. Yeah.
I don't know. We're getting into a real weird future where you have to carry a Faraday cage.
Can we just go back to something Anastasiia said, which I think is something that we should be teaching developers as well. And she talked about defense in depth. And that is something that again, Java developers should learn about. And that comes to them starting to write putting out logging information and tracing information about the behavior of their application, and that it's not working the way that they're expecting. Because so much of defense in depth is you have all the layers, but it's also all the warning systems that weird things are happening. And it's just another thing to put on the list for Java developers to learn.
All right, that covers a lot of really good information about security, both of applications as well as Java applications. So I want to say thank you very much, first of all, for the guests and also for the listeners. And keep an eye on Foojay for future articles about development and everything related to the OpenJDK world. Thank you very much.
Give me a Foo, give me a J, give me the friends of OpenJDK.